Hello GATE aspirants, welcome to part 9 of GATE electronic series. Question 11. The logic expression is given to us. A bar B C or A bar B bar C or A B C bar or A B bar C bar can be simplified. So let us simplify it. We can take A bar common from this and C as well. So we'll get B or B bar, or we can take AC bar common. So this will be B or B bar. Now B or B bar, that will be 1. So this will be A bar C plus AC bar. So this is XOR. So this will be option A XOR C. So option A is correct. Next question. In a 2:1 multiplexer as shown below, the output X is equal to A0 if C is 0 and X is equal to A1 if C is 1. So output will be A0. So A0 should be outputted to X when C is equal to 0. So in the output all gates are OR gates. So you can check by options. So in option A, if C is equal to 0, then this will be 1 and A0 will be outputted to X. And if C is 1, then A1 will be at the output. So here option 1 is correct. Next, for an operational amplifier circuit shown below, if V1 is equal to 1 volt, so this is 1 volt, and V2 is equal to 2 volt, then the value of V0 is. Now let us consider this voltage to be V2 and this voltage as V1. Now by the concept of virtual ground, V1 will be equal to V2. So V1 will be equal to V2, but V1 is connected to ground, that means V1 is 0, that means V2 is also 0. Now at this point we can use KCL. Now the input currents are, let this current be I1 and let this current be I2 and this current will be IF. So according to KCL, input currents, that is I1 plus I2 will be equal to IF, and I1 is equal to V1 minus this voltage, let us assume this is V, so V1 minus V upon R1 plus V2 minus V upon R2 is equal to V minus VO upon RF. Since V is equal to 0, we will have V1 by R1, that is 1 volt by 2 kilo ohm, plus V2 is 2 volt upon R2 is 5 kilo ohm, is equal to minus V0, RF is 4 kilo ohm. You can cancel this kilo ohms. So this will be 1 by 2, that is 0.5, 2 by 5, that is 0.4, and that is equal to minus V0 by 4. So this will be 0.9 is equal to minus V0 by 4. So V0 is equal to 9 into 4, that is 36. So minus 3.6 volt. So the answer is minus 3.6. And the answer key or the range for the answer for this question was 3.7, minus 3.7 to minus 3.5. Next question, 39. An N-channel field effect transistor having gate source switch off voltage VGS off is equal to minus 2 volt is used to invert a 0 to 5 square wave signal as shown. The maximum allowed value of R would be. So we have to find value of R. Now this point is gate and this corresponding voltage, let it be VG. This is source and this is drain. Now in this case, let us find out VG first. Now voltage at gate will be because of these two sources, V in and this minus 12 volt supply. Now here it is given that this voltage is used to invert this square wave signal. That means if V in is 5 volt, V out will be 0 volt. Now this VG is because of V in and minus 12 volt. So we will use superposition theorem. That means when we are considering V in, this source will be grounded. So VG is equal to V in, and that will be voltage across 1 kilo ohm resistor. So this will be 5 into 1 upon 1 plus R. I am taking R in kilo ohms. Now when we are considering this minus 12 volt supply, then V in will be grounded. So this will be voltage across R. So this will be minus 12 into R upon 1 plus R. So this will be Vg. So Vg is equal to 5 minus 12R upon 1 plus R. So this is the value of Vg. Now let us consider in this part. Here Vg minus voltage across gate source, that is VGS, that will be equal to voltage across RS resistor, that is ID into RD. But when VGS is equal to VGS off, in that case this is off, that means ID is equal to 0. So ID will be 0. That means Vg will be equal to VGS off. VGS off is given, that is minus 2 volt, and Vg is this. So 5 minus 12R upon 1 plus R is equal to VGS off, that is minus 2 volt. So let us solve this for R. So 5 minus 12R is equal to minus 2 minus 2R. So this will be 5 plus 2 7, and 12R minus 2R, that is 10R. So R is equal to 7 by 10, and this will be in kilo ohms. That means 0.7 kilo. That will be value of R. And the answer range for this question was 0.70 to 0.73. So this will be 0.70 kilo. These are all the questions from electronics part of GATE 2018 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.